everywhere. We encounter it every day as a part of our daily living. It can be in the form of a water wave, sound wave, or light wave. Last time, we gave an introduction about mechanical wave, and we defined it as an oscillation of matter that travels through a medium. Today, we are going to dig deeper on the mechanical wave by discussing the two of its wave motion, the transverse mechanical wave and the longitudinal mechanical wave. So let's start! Have you ever seen this kind of wave motion? This is what we call the transverse mechanical wave. Observe the movement of the transverse mechanical wave. You will see that the transverse mechanical wave produces a high point and low point of a wave. These two are called the crest and the trough. We should always remember that the crest refers to the high point of the wave, while the trough refers to the low point of the wave. Next thing to remember is that the vertical distance between the crest and the trough is called wave height, while the distance between any two consecutive identical points on the waveform is called wavelength. Example of it is the water wave. Now I want you to observe the movement of the water. You will observe that as the object hits the surface of the water, there is a continual disturbances that creates a wave crest. The disturbance is in the surface of the water created by an object. We must always remember that none of the particles are transferred a transverse mechanical wave. Instead, they moved up and down perpendicular to the direction of the wave as the wave transmitted through the medium.
So what's next?
Let's now move on to the longitudinal mechanical wave. Longitudinal mechanical wave vibrates parallel to the direction of the wave. Example of it are the sound wave, the ultrasound wave, and the seismic P waves. This longitudinal wave shows an area of compression and rarefaction, while the compression refers to the regions of high pressure due to particles moving close together. Rarefaction refers to the low pressure due to particles being spread farther apart. Observe the movement of the longitudinal mechanical wave. You will see that the compression moves from left to right. Thus, the energy transferred from left to right. But take note, none of the particles is transferred in longitudinal mechanical wave. Instead, they move backwards and forwards between the compression as the wave transmitted through a medium.
Let's now have a short recap.
Earlier, we discussed that when the movement of the particles is perpendicular to the direction of the wave, it refers to transverse mechanical wave. But when the movement of the particles is parallel to the movement or the direction of the wave, it refers to longitudinal mechanical wave. We also repeated twice that none of the particles is transmitted in either transverse mechanical wave or longitudinal mechanical wave. Well, I think we're done. Hope you learned much today. Have a blessed day. Thank you for watching.